You may already know that wiring can sometimes be a very daunting task, especially when it comes to wiring something as complex as a complete engine swap. Swapping an engine into a chassis that was never meant to run that engine can be extremely difficult because it will often need modified mechanical parts and a custom engine harness to run the engine properly. So how exactly do you know what all you need in your engine harness to swap a 2JZ into a 350Z and get it running properly? The first step is to know what you're using your car for, and with that, what components of the engine are you going to need for the swap to achieve its purpose. Knowing the purpose of your build can add or eliminate complexity to your engine harness. For instance, if you're building a track car, you may not want to have air conditioning. If you're building a daily driver, then AC might be a necessity. Maybe you want a drag car where you don't need power steering or variable valve timing, since all the straight line power you're going to be getting is from a big turbo. Adding or deleting a system from the engine, such as variable valve timing, will add complexity or remove complexity from the harness because connectors are going to be added or removed as well. And since the harness is responsible for relaying information from these components back to the ECU, just know that the more components that there are, the more complex the harness has to be. Now, I'm sure you've probably got a pretty good idea of what you already want to do with your car, so I might as well just go ahead and tell you all the things you're going to need to get it running. So I've got a list here on my computer to my right. I'm going to go ahead and just start reading off everything that I've listed down. These are all the basic sensors and components that you're going to need to run your engine and the other accessories that we typically consider to be a necessity. So the first thing is I want to go over air conditioning. If you want air conditioning in your car, you're going to need either a 2JZ or a 350Z AC compressor. So the 2J AC compressor is going to be a direct bolt-on to the 2JZ. However, you would probably have to modify the AC lines in the 350Z chassis in order for the 2JZ compressor to work. On the contrary, you could use a 350Z compressor, but you would have to modify a bracket to adapt that compressor to the 2JZ, but it's likely that you won't have to modify the AC lines at all. In addition, the 350Z AC compressor is going to have a different wire connector than the 2JZ, so just accommodate for that when you're planning on buying or making a harness. Regardless of which compressor you choose, both of them are going to have a magnetic clutch and lock system, so that sensor is essentially covered as long as you have one of the two compressors. Next up is the rotating assembly position sensors, which basically includes your camshaft position sensors and your crankshaft position sensor. So it really depends on what engine you have for what sensors you're going to need. All but one variation of the 2JZ is going to need a crankshaft position sensor. Everything with the exception of the GE non-VVTi, you're going to need a crankshaft position sensor on. So I would just use the Toyota one that goes into the oil pump. If you have a VVTi model engine, you're only going to need one camshaft position sensor. If you have a non-VVTi GTE, you're going to want two camshaft position sensors for the front and the back of the intake camshaft. And if you're using a GE non-VVTi, everything is controlled by the distributor on the exhaust camshaft, so you should not need any camshaft position sensors at all. And all of these sensors are essentially necessary for keeping the engine in time. For my particular motor, I'm going to be using one camshaft position sensor because I have a 2JZ GTE VVTi and one crankshaft position sensor. Next up would be the coolant temperature monitoring. You're going to need at least one coolant temperature sensor of some sort. So normally on the 2JZ, on the exhaust side where the water pump is, there is a temperature sensor for the coolant there that monitors the coolant temp. That gets relayed to the ECU. You're probably also going to want a temperature sender. This will actually send the temperature to the gauge in your car so you can monitor it and you can watch it live. And then lastly, it's definitely recommended that you have a coolant temperature switch mounted somewhere near your radiator or on it. That way, when your temperature of the coolant raises or lowers, That switch can relay information to the ECU to let it know whether or not your radiator fans need to turn on or off. And following the coolant sensors will be the oil sensors. One of the most common ones is the engine oil level sensor. This sensor is optional. You don't have to monitor your engine oil level. It is pretty recommended that you do though. For my specific application, I'm not going to be running one. That may trigger a light on my dashboard with an aftermarket ECU, but that's okay. I'm going to be checking the oil pretty regularly, so I shouldn't have to worry about it. In addition to the oil level sensor, you're either going to need an oil pressure switch or the VVTi solenoid, depending on which motor you have. If you're running VVTi, obviously you're going to need the VVTi solenoid. If you don't have VVT on your engine, you're going to need the oil pressure switch. So the oil pressure switch monitors the oil pressure, and the VVTi solenoid monitors pressure and controls the timing on the intake camshaft. Non-VVTi engines are going to require an oil pressure switch, where VVTi engines are going to require a feed hose that goes from the same location that the oil pressure switch would be and feeds it up into the VVTi solenoid, which in turn controls the oil control valve, which controls the variable intake timing. Next up is going to be the alternator wiring. Pretty much any car is going to need an alternator in order to keep the battery charged, and there's two simple connections you need for that. The first one is going to be the ground wire to ground the electricity, and then the generator plug. So there's just going to be a sensor connector on the alternator, and you need to have that wired into your harness. And after that, it would be advisable to look at an O2 sensor or two. It depends on how you want to run your engine. Sometimes people don't run oxygen sensors at all. I would definitely recommend that you have at least one before your catalytic converter. That way your ECU can calculate whether your air fuel mixture is correct. And if you want to have a catalytic converter, you should probably have another oxygen sensor right behind it to make sure that your catalytic converter is doing its job at burning excess fuel. Now, a very important sensor you're going to need is the idle air control valve. You could probably get this for the Supra. If you have a stock GTE intake plenum, you will have an intake air control valve attached to it. If you are building your engine similar to mine, I'm probably going to have to run an aftermarket intake air control valve. I'm likely going to be using one from a Ford Mustang with an adapter. Next up is ignition. Ignition is going to be dependent on exactly how your engine is supposed to be run. So there are different versions of the GTE and the GE, like I mentioned earlier. Some of them require coil packs, some of them require a distributor. For coil packs, it's going to eliminate the need for separate igniters and coils. If you're running coil packs, all you're going to have to do is put your coil packs on the engine and have a separate wire for each one of those. And for engines with igniters and coils, you're going to need to have connectors for both of your igniters and then connectors for all 6 of your coils. And in addition to that, you're probably also going to need a noise filter, which is there to eliminate electromagnetic fields that might disturb other electronics within the car, which, by the way, you won't need a noise filter if you're doing coil packs, so you should probably get some coil packs. And in tangent with ignition is fuel injection. You're going to need 6 injectors. If you have high impedance injectors, you will not need to run a sequential fuel injector resistor. That basically keeps it from damaging the ECU, and in that case you would be running low impedance. So low impedance, you're going to need a resistor. High impedance, you are not going to need a resistor. You are also going to need NOx sensors. There is one on the front of the engine and one on the back. Every 2JZ had 2 of these. And if you plan on running power steering, you're going to need obviously a power steering pump, and also what Toyota calls the PPS solenoid, or the power steering pressure solenoid. Don't know why they called it PPS, but that's going to have to be wired into your harness as well in order to control that. And then obviously you're going to need wiring for your starter. So just like the alternator, you're going to need a plug to activate it, and then you're also going to need a ground. And then you're also going to need a throttle position monitoring system of some sort. So if you're reusing the OEM Toyota Supra GTE intake throttle body, you're going to want to have the sub throttle position sensor, the sub throttle valve motor. If you're going to be setting up your engine the same way I'm setting up mine, you're likely going to be using a Q45 drive-by-wire throttle body that's very similar to the 350Z. The reason I'm doing that is because I don't want to have to mess with changing the pedal, running a cable to my throttle body. I'd much rather everything be controlled by wire the same way that the 350Z was from factory. And lastly, one of the more important things is going to be the vacuum system. If you're running a big turbo, you probably won't have anything to do with this, and the only vacuum you've got to worry about is probably your brake booster. For my application, where I've got both of the twin turbos that are completely controlled by vacuum switching valves, I'm going to need to include a few sensors to regulate the vacuum. For my setup with the OEM twin turbos, I'm going to need a turbo pressure sensor, which is the equivalent of a manifold absolute or air pressure sensor. It basically just monitors the air coming into the intake after it's been compressed by the turbos. If my engine were to have exhaust gas recirculation, which it doesn't since it's a JDM motor, that was a US motor thing only, I'd have to include part of that. So since I don't have that, I'm just going to block off the vacuum ports for that. As for all the sensors that I do need, I'm going to need a vacuum switching valve for evap, the bypass valve, the exhaust control valve, fuel pressure, the air intake, as well as a vacuum switching valve as well as a vacuum switching valve for the wastegate. So I've got all of those sensors. If you are running the stock twins, you are going to need all of those as well. They're the only thing that helps the sequential turbo process function sequentially. Without those, you would either have a turbo completely blocked off or completely open at all times. But knowing most of you guys, you're probably going to be running a big turbo, and that doesn't concern you at all. Now, if you got all of that information down, it's completely up to you whether or not you want to decide to buy or build your own harness. Buying a harness is a lot more expensive, but it in turn requires a lot less work. You just have to find a manufacturer to make it, tell them all the sensors you need, the ECU you're going to be running, and a little bit of information about your car. If you're like me and you plan to build your own harness, you're going to need to know which ECU you plan to run, the pinouts for the original ECU for your car, and lastly, the pinout for the 2JZ engine harness if you have one. So knowing the layout of all the wires on a connector pinout diagram from the motor harness and from the OEM ECU helps determine which wires will go where on the new ECU. From there, you can direct the wires from the engine harness and the chassis to your aftermarket ECU in the corresponding locations, and then figure out how to tidy up your harness once everything is connected. If you would like to see somebody put the harness together themselves, I am going to be covering that on my channel. I haven't started quite yet, but I do plan to cover every bit and piece of me putting that harness together to the best of my ability. That way, people like you who are wanting to do it yourself can see how someone else is doing it. That way, you can look at my work and think whether or not you want to do it the same way, or if you want to add or subtract something from your application. That being said, if you're interested, just keep up with my series of videos. I'm going to continue posting about how to make whatever I make, how to make this swap happen, step for step, part for part, and then eventually include the cost of everything at the end. But I believe I've covered everything as far as the necessary sensors and components to get your engine running. Everything else is basically going to be an accessory from there. So with that, that's the end of this video. Thank you for watching. If you enjoyed the content or were able to learn something from it, be sure to give it a like. It would be much appreciated. Consider subscribing if you'd like to see more of my videos. I'd like to help you guys out with as much information as I can that I learned from this project. And if you have any questions or concerns, feel free to post them down in the comments. I try to respond to all the questions the best I can. But anyways, yeah, that's it for this one. Make sure to make the rest of your day a great day. Peace out. See you guys in the next one.